Hi, everyone at ICSI. I'm Margaret Ann Story from the University of Victoria in beautiful British Columbia, Canada. And like many of you, this is my first time attending and presenting at a virtual conference. Quite the change from ICSI from last year in Montreal. Today, I'm using a photo of some of my colleagues and friends to feel a little less lonely as I present to a webcam. For this short presentation, I have the pleasure of presenting a journal-first paper about a theory of developer satisfaction and productivity, joint work with Tom Zimmerman, Chris Bird, Jacek Cerwonka, Brendan Murphy, and Irini Kaliambaku. This research started when I visited Microsoft for a sabbatical in 2017. I was hosted by the 1ES team that is responsible for building the engineering systems for most of Microsoft. And one of their mandates is to understand developer satisfaction with engineering tools. But they also wanted to know what other factors may affect engineering satisfaction and productivity. Understanding knowledge work satisfaction and the relationship with job performance has been studied for several decades. Early in this research, many assumed there was no relationship between satisfaction and performance, or at best a unidirectional relationship between the two. However, a meta review by Judge et al. Showed that there is a bidirectional relationship between the two, and that other factors mediate that relationship. They also showed that this correlation between job satisfaction and performance is likely higher for more complex work. Consequently, we expected this theory would hold for software developers, but we didn't know what specific factors may associate more closely with satisfaction and performance. So our goal for this study was to identify which factors, as well as which challenges, may impact satisfaction and productivity. And we also wanted to identify if work context variables may play a role in these relationships, variables such as the kind of work a developer does. Our research methodology followed three phases. First, weeks of on-site informal interviews and an in-depth literature review led to a preliminary set of 30 factors and 15 challenges. We then conducted a survey answered by 591 engineers to confirm these factors and challenges, and identified an additional 14 factors and 9 challenges from open-ended responses. We conducted a second survey answered by 465 developers to probe how important they thought these factors were to them and how satisfied they were with the factors. And we also identified the impact of the 24 challenges in developer satisfaction and productivity. This is how the second survey looked for the importance question with the 5-point Likert scale. And I'll note that no new factors and challenges emerged from this second survey. Looking at the challenges, we found that the presence of some challenges were associated with lower satisfaction of several factors. For example, the challenge of a poor manager was correlated with lower satisfaction across 16 different factors. We anticipated that some of the 44 factors may be related, and so we clustered them into composite factors using a correlation cutoff of 0.5 and identified 20 composite factors. For example, we clustered factors that relate to the engineering system, doing impactful work, culture of work, their work environment, and feeling they are an important team contributor. We built a linear regression model with standardized coefficients showing how these composite factors influence overall job satisfaction for developers. And the main factors in this model are doing impactful work, feeling they are an important team contributor, and having a good work culture. And we see that perceived productivity influences more positive job satisfaction. A second linear regression model shows how the composite factors influence perceived productivity for developers. And the main influencing factors were work autonomy, the engineering system, and doing impactful work. And again, we see job satisfaction as a factor in the model for higher perceived productivity. As we built our models, we also considered different work context variables. And here we show which challenges and factors appear in a model that focused on developers who code less than 37% of their time. Like any study, there are limitations that we discuss in our paper, but we note that our findings align with other studies that consider similar constructs or different settings. Our findings resonated with developers and management at Microsoft and helped them understand that improving developer satisfaction and productivity requires attention to many different factors. To conclude, we found that for the developers we studied at Microsoft, doing impactful work and being an important contributor are associated with both satisfaction and productivity, while appreciation, a good work culture, and work-life balance are important for higher satisfaction. While autonomy over one's work, ability to complete tasks, a good engineering system, strong technical skills, and a positive work environment are associated with higher productivity. Most importantly, we also found that a developer that feels more productive may feel more satisfied and vice versa. And so steps taken to improve productivity that may lower satisfaction may ultimately lower productivity. Care has to be paid to both aspects. I look forward to hearing your questions and comments at the conference, and again, thank my collaborators for their contributions to this research and paper. Thank you.